Okay, this next lesson is about tangents to a circle, and we're going to be using the Pythagorean theorem a lot. So let's remind ourselves what the Pythagorean theorem is. And it is, remember, that a squared plus b squared equals c squared. So in this case, a and b are your two sides, right? And remember, c always has to be the hypotenuse, which is the opposite of the right angle. So in this case, we'd have x squared plus 4 squared equals 12 squared. So we'd have x squared plus 16 equals 144. Subtract 16 from both sides, and we get x squared equals 144 minus 16 is 128. And then we take the square root of both sides. In this case, because it tells us to put it in simplified radical form, we're going to take, remember, 128, and we're going to see what it's divisible by. So 128 is divisible by 4 as an example. So we get 4 and then 32. And 32 is divisible by 4 and 8. So let's break down 8 and we get 4 and 2. And then we can break down 4 and we get like 2 and 2. Remember, anytime you have pairs, we technically could break this 4 down into 2 and 2 again, but if I've got a pair of 4s and I've got a pair of 2s, then we write one set of the pair. So in this case, we'd have, right over here on the right, x equals 4. That's one set of the 4s, and then one set of the 2s times 2. And then we've got a leftover 2 that we'll say inside the square root. So in this case, our answer would be 8 square roots of 2. Sometimes they'll have you leave it in radical form, and other times they'll have you use decimal approximations on this assignment. Okay, so that's going to be like your first problem, just a little introduction. Next, we're talking about this theorem that says if a line that is tangent, what it means for something to be tangent is as you look over here on the right, if it just touches the circle, see in that one spot, then that line that touches the circle only at one point, we call that a tangent line to the circle. And if that is the case, then you'll notice we will get it's perpendicular to the radius drawn to the point of tangency. So if we connect C to T, we'll get a right angle right there. So if we go over here on our left, we're going to fill this in with perpendicular. And the cool thing is, if I then connect like C to some point else on that line that's tangent, I'll get a right triangle. And that's mostly what we're working with here. So here we have in our circle O, RP is tangent. Okay, great. So that means that length of 12 is tangent. So this is a right angle right there. It says find OR. So in this case, this is going to be our C, right? It's our hypotenuse. So we're going to have 5 squared plus 12 squared equals C squared. So we're going to have 25 plus 144 equals C squared. 25 plus 144 is 169 equals C squared. Take the square root of both sides, and C equals, if you're not quite sure, I'd always just try like square root of 169 in your calculator, and this time it turns out nicely. It's just 13. Okay, let's look at the next one. Find the missing segment. Assume the lines which appear to be tangent are tangents. So they're saying, hey, this is a right angle. And in general, in this whole lesson, I would just assume that you got that right angle there on the outside. So the tricky thing about this one is we've got our side A. We don't know our side, let's say B, and then we do have the hypotenuse, right? And that is the entire length. So we're going to have 7.2 squared plus B squared equals 9.7 squared. So we type in 7.2 squared in our calculator, we get 51.84 plus B squared equals 9.7 squared is 94.09. Subtract 51.84 from both sides, and we end up with B squared equals 42.28. Since this is not an integer, we're going to get a decimal as an answer anyway, so this one you probably would approximate. So I would just type in the square root of 42.28 on your calculator, and you end up getting B is approximately 6.5. Okay. This one, we're going to find this length BCX. The tricky part about it is they gave us this one side length, 21. So we know we'd have x squared plus 21 squared. right? It's a right angle up here. But it doesn't make sense that 14 is my whole hypotenuse. So sometimes they give you just this length from the edge of the circle to where point C is. The hypotenuse should be the longest side, so in this case it should be greater than 21. So what they're wanting you to recognize here, if they just give you this little length here, right, that you also know, so the radius of the circle from A to B is 21, therefore the radius from A to the edge of this part of the circle is also 21. So this entire length of the hypotenuse is 21 plus 14. So 21 plus 14 gives me a length of 35 meters for that part. So we're going to have 35 squared. And I think the hardest part about that one was just recognizing, hey, I needed to add something to actually get the hypotenuse there. So we get x squared plus 441 equals 1,225. Subtract your 441 from both sides, and we end up with x squared equals 798. Sorry, 784. I totally said the wrong number there. When you take the square root of both sides and you check in your calculator, you get the length of x to be 28. In this case, since I was talking about meters, this would be meters as well. Okay, let's look at this next picture. The next picture, they actually ask you to find the radius. And they're telling you, hey, this is a point of tangency, so you do have a right angle there. So we could say like, hey, 12 is our side length A. R is equivalent to B. Be careful here. Remember, like just like we did in this last problem, this whole hypotenuse is more than just 8, right? The length here is 8 plus R. So we're going to have 12 squared plus R squared. And yes, use R rather than B and C because we want to use the same variable, not have two different ones. And we're going to have it equals 8 plus R, right? That entire length squared. So this is 144 plus R squared equals. Let's talk about what 8 plus R squared really means. That's really 8R, 8 plus R times 8 plus R. Think about distributing back to quarter 1. We get 8 times 8 is 64. 8 times R is 8R. R times 8 is 8R. And R times R is R squared. So over here we'd have 64 plus 8R is 16R plus R squared. So let's combine our terms. I'm going to combine the R squareds. Hey, that's really nice. They cancel out. Congratulations. You don't actually have to solve a quadratic. We're down to a linear now, although we did get a quadratic there for a minute. We get 144 equals 64 plus 16R. Subtract 64 from both sides. And we end up with 80 equals 16R. Divide both sides by 16. And you get that the radius is 5. Which means that, hey, this length BC is 5, but then the whole hypotenuse would be 8 plus 5 or 13, which makes sense. Okay, that's it for tangents to a circle. We're going to start to kind of incorporate some review problems, particularly some trig, because that's kind of the part that got cut short when we ended up breaking up for school. So the very last problem on this assignment is actually going to be a review problem about some trig. So we're going to review sine, remember, so, cosine, ca, tangent, TOA. So from this angle theta, the opposite side is the 8, right? The hypotenuse is always across from the right angle, so that's going to be the 17, which means the side right next to the angle is the adjacent of 15. So if we wanted sine of this angle theta, we would do opposite of 8 over 17. You're fine to leave it as a fraction, or if you'd like to divide that on your calculator, just make sure you round 3 decimal places. I'm going to leave it as a fraction. Okay, let's do cosine. So cosine of theta is going to be the opposite side, which is 15, over the hypotenuse, which is 17. Last but not least, we've got tangent. The opposite side is 8, and the adjacent side is 15. And you're all set. You should be good to go with the 11.3